All right, we're here on page 5 for section 2.1. We have done a lot of solving equations, and now we get to move into the practice plus and application exercises. In the practice plus, the instructions say use the given info to write an equation, use x for your variable, and then solve. So I wanted to let you work through those on your own. I don't want to spoil the fun. That's the silly way of saying it. What I really want to do is I want to make sure you get the best learning out of this possible. So I just wanted to tell you what you can expect on those. You can expect to translate the information that they've given you to an equation that we're used to seeing in this section. In other words, it's going to have that linear look to it, that ax plus b equals c form, where you've got something multiplied by x, something added or subtracted from it equal to some other value. Okay, and then you'll solve using the same steps that we've done before. You have the goal of getting x by itself. And then look for parentheses, look for like terms, look for x on one side, but all that will be done for you because you're just setting it up already in that ax plus b equals c. And then ask what's happening, undo that list, check your answer. Okay, so same steps as we've done all the way through 2.1. The key words that you'll want to look for to help you set up the equation is so that you can know where to put the equal sign are words like is, result or results in. They even sometimes just use the word equals, and that'll tell you where that equal sign is supposed to be. Okay, now I'm going to adjust the camera a little bit because I want to look at this application exercise, and so pardon the shakiness, but let's do this one together. Just going to make sure that stayed in focus. Good. Okay, so here's an example of an application exercise you'll see in this section, number 68. And once again, if you go straight to the number in the book, you'll see a description and a question, but it won't make sense until you look further up above that, or maybe on the next column over to before 68, where they give you the graph of the real data and then the mathematical model here. And actually, the graph here is an actual graph of this model. Sorry, I'm realizing what I'm looking at here. So they took some data, turned it into an equation here, and then this is the line of the equation. This is the graph of the line here, of the linear equation. Okay, right here. And a mathematical model, that's the same thing as formula, that's the same thing as an equation. Okay, those all mean the same thing. So let's read what we're given here. We've got a line graph. It shows the decline in U.S. job satisfaction. So as the line goes down, that's how they're interpreting decline. For 4 years in the period from 1987 through 2006. For 4 years. Oh, I see. Because here's the data. So they took these 4 points of data. They measured it 4 different times, and then connected them for a line here. Okay. And we've got percentages of satisfaction up on the left, and down here going across is your years. The graph was obtained from the mathematical model S plus 0.8x equals 62, where S is the percentage of workers satisfied with their jobs X years after 1987. Use this information to solve exercises 67 through 68. So the reason why I wanted to go through this one with you is because we've got 2 variables here, and I don't want that to throw you. Okay, we're just getting practice seeing what happens when we have a linear equation and we connect the graph to it and what those values mean. So let's read through what they give us here. Use the line graph to estimate the percentage of U.S. workers who were satisfied with their jobs in 2000. So we're using the line graph first. So this is the line graph over here. We need to go to 2000 and find out the percentage who were satisfied. Okay, so we go to 2000 on the graph. There it is right here. we're going to go up, and we see that little dot, and we kind of go backwards, kind of estimate, and it landed somewhere between 50 and 55. I'm going to say that's around 51, 52. Okay, so about 51 or 52% satisfied with their jobs, according to the graph. Now, we will use, part B says to use the formula to determine the percentage of U.S. workers who were satisfied with their jobs in 2000. So, same exact question, same year, we're looking for a percentage, satisfied, and S represents that, but now we're using the formula this time. So, we look at this, we copy down the formula here, S plus 0. Make that really look like an S, so I don't think it's a 5 later on. S plus 0.8 times X equals 62. We're going to use the year 2000, and we want to find S, and it equals a percentage. So we don't have to create a percent or anything like that. When we get S, it will equal the percentage. Just like when we traced it over here on the graph, it was set up to represent a percentage. Okay. What we don't want to do is put 2000 in for X. X doesn't equal 2000. X equals, based on what they tell us here, X represents years after 1987. So you take 2000, the year we're interested in, minus the 1987, and that equals 13. So that is our X value that we're going to plug in. Okay, so we're going to plug in 13 for X. So we've got S plus 0.8 times X equals 62. 13 is what we're going to plug in here. And that gets us S plus 0.8 times 13 is going to be 10.4 is equal to 62. Remember, chapter 2, we're a fresh exam, so we're headed for, sorry, that's not what I wanted to say. Chapter 2, calculators are okay on this next exam. We're out of chapter 1, which is the no calculator area. And this next exam will actually be chapter 2 plus a little bit of chapter 3, about 2/3 of it. So, but you can see all that on the calendar and schedule. Okay, continuing on here, now we have an equation that we're used to solving, and we do all the steps that we've been used to doing this whole time. We check for parentheses, done. We check for like terms, there aren't any, that's already taken care of for us. We make sure the variable that we're solving for, S in this case, is on, make sure it's picked aside, one side or the other, just the one, and it is. Then we look to see what's happening to S. And right now there's only one thing, and that's that we're adding that 10.4. Or if you want to do that in a more visual manner, you could say you've got S, and then you add 10.4. We're not necessarily just copying the equation there. We're telling a little timeline. Then you undo that list. That's how you solve it. Once you describe what's happening, you just go in reverse order. So it's up the list or it's right to left through the timeline here. And instead of adding, you do the opposite, and that would be to subtract 10.4. Or if you're going to use the timeline method, you'd go across here from right to left. We see plus 10.4. We're going to do minus 10.4. And then that's what you do to both sides. Minus 10.4, minus 10.4, and we get S equals 62 minus 10.4 will give you 51.6, and that is, the formula gives us 51.6% satisfied with their jobs in the year 2000. Now, how did that compare with your graphical estimate from part A? Well, we estimated somewhere between 51 and 52%, and so it's a good comparison. As close as possible. So, yay for us. Okay, so that's an example of what you do for the application exercises. So just follow what it says. Be very careful to notice if they're telling you to use a graph or a formula, and then finish answering the question if they ask you to do any comparison. Don't forget, you'll wrap up with some review and some preview exercises, and then you have completed 2.1. We'll see you in 2.2. Good job.